Hello everyone. In this video, we are going to discuss about the queue data structure and the operations performed on the queue. So let's start with the definition. A queue is defined as a linear data structure which works on principle of first in, first out. The first in, first out means whichever element will be inserted first, that will be deleted first. It means the element which is coming last, that will be deleted last. So the practical example of queues are many. For example, ticket counter, bank, or in the mess, everywhere we get first come, first serve principle. Let's see other definition of queue. Queue like stake. This is also an abstract data structure. The thing that makes queue different from the stake is that the queue is open at its both ends. Means, unlike stake, we perform insertion and deletion from different end. In the stake, we perform insertion and deletion from same end. But here in the queue, we'll perform deletion from front end. The name is front, and the insertion we will perform from the rear end. So let's take one example. Here, I'm taking 4 size array where we have 6, 7, 8. Now you know that the first element inserted is 6. So I can delete the 6 only at first. Then I can delete 7. Then I can delete 8. So in this way, this will be for deletion. This end, basically it is called front end. And if I want to insert the element, then I will use this end. And that end, usually we will call it rear. There are two ends in the queue. Now, let's see the characteristics of the queue. The first characteristics, obviously, you will say that is first in, first out. Then second characteristics is obviously it is a linear data structure. Then, if you want to implement the queue can be static data structure also and dynamic data structure also. Means queue can be implemented using the array also, or we can use the dynamic data structure for creating the memory in the queue. We can access both the ends. Why? Because we are deleting from the front end and inserting from the rear end. Insertion and deletion, like stake, it is very fast. Means the complexity of the insertion and deletion is theta of 1. Now you can understand from here, let's suppose we have 3 elements, 6, 7, 8, and you know that if we want to delete the element, obviously we need not to go anywhere, just we can delete 6. If I want to insert the element, directly I can insert here in the constant time. Meaning is we don't have to traverse for n elements. That's why the complexity of this is theta of 1. Then if we want to traverse or if we want to search any element from the queue, then the complexity will be theta of n. Why? Let's suppose we have total n elements. And if we have n elements, then if we start searching from 6, then it will go up to n elements. Can go up to, in worst case, can go up to n elements. That's why the complexity is theta of n for searching. And if we traverse also, then it is the same thing. We want to display all the elements. Then from 0 index to up to n minus 1 index, we have to traverse all the nodes. That's why the complexity is theta of n. Here, we are going to perform two main operations, which is insertion and deletion. The insertion usually we call Enqueue in the queue, and the Dequeue stands for the deletion in the queue. Now we will see the working of the queue, how the queue is going to be work. Let's say we have an empty queue of size 5. The size is given is equal to 5. This is the index 0, 1, 2, 3, and 4. So we have 0 to 4. These are the index. Now, initially, when the queue is empty, then your front value and your rear value will be initially assigned to -1. The front and rear both are -1, means we can say that queue is empty. Okay. When we insert the first element, let's suppose now I'm inserting one element here, that is 2. If I insert the element will come at the 0 index. So first you are increasing the value of front and rear. If you increase the value of front and rear, then it will become 0. And finally, the element will come on the place of 0 index. So first time when you insert the element into the queue, that you have to take care that both the value of front and rear we have to increase. On the second time onwards, we have to just increase the value of rear only. So if I insert the next value, let's suppose I want to insert now 1, then only I'm going to increase the value of rear. Front will remain here only. So if I increase the value of rear, means I am doing basically r is equal to r plus 1. And then finally in the array, I'm going to insert a of r is equal to 1. So the rear will come here. The rear is equal to rear plus 1, means rear will be 1. And the value at the index 1 is finally will be 1. Now, let's suppose I want to insert one more element here. If I insert one more element, obviously it will come after 1 only. Means we have to increase the value of rear. The front will remain here only. These are the index 0, 1, 2, 3, 4 and 2, 1 was there earlier. So again what we'll do, if we insert r is equal to r plus 1, we are going to do, the value of r will increase to 2 and a of r means a of 2 I am going to insert now 4. So finally 4 will come here. So in this way, these are the two basic things we are going to do when we insert the element into the queue. Now, let's suppose I want to delete the value. Now, if you delete the value, there's no need to say delete 2 because automatically it will delete the value 2 only. Because the first element we inserted in the queue was 2. So when you delete the element, then you have to increase the value of front and not rear. That's why we say when we delete the element, we have to increase the value of front. So when you delete, just you do front plus plus. Again, let's suppose I want to delete the element. If again I want to delete the element, then again you increase the value of front. So if I delete now, it will remain 4 only. Now we have remaining with 4. Now here you have to see the scenarios which I am telling you. Here you can understand when we have front is equal to rear. When front is equal to rear, then we can say we have only one element left. Even here, you are seeing that front and rear are equal, and here also we have one value. Except this. This is the value, this is the condition where we can say Q is empty. But in other cases, when the front end is equal to rear, means we have only one element left. Let's suppose one more time I want to delete. If one more time if I want to delete the element, then the value of front will again increase. Means 4 is deleted. 4 is deleted. In this case, now your queue is empty. So here you are getting one more scenario when the value of front, F means front, is greater than rear, then you can say your queue is empty. Your queue is empty. So these are the few scenarios which you will come across when you do insertion and deletion. So here, after this scenario, let's suppose I want to insert two more values. So one more scenario I want to tell you. That's why I'm inserting now here two more values. So these are my index 0, 1, 2, 3, 4. This 2, 1, 4 was already there and front was also there. So if you insert two more value, let's suppose 6 and 7 you are inserting, the value of rear will come on index number 4. So you can understand from here that when the value of R is equal to 4 and the value of R is size minus 1, then you can say that our queue is full. In this case, we will say our queue is full. So here we have discussed some scenarios. You can understand these scenarios and this will help us to write the algorithm of insertion and deletion. And now we will come to the algorithm of insertion and deletion that is called Enqueue and Dequeue. So step number one. Step number one is if rear is equal to max minus 1. Rear is equal to max minus 1. What is the meaning of this? Let's understand that. If rear is here, it's max minus 1 means we have queue completely filled. Queue is completely filled. So we will say queue overflow. And we will go to step number 4, that is exit. So while inserting the value, first we will check whether the queue is full or not. If the queue is full, then we cannot insert the element into the queue. Second, step number 2, when front and rear both are minus 1. This case already we understood. When front and rear both are minus 1, then we have to set first of all front and rear both is equal to 0. Then we'll go to step number 3, which is queue of rear is equal to num, means we are inserting the value at this 0 index. So when front and rear are minus 1, the front and rear will come here. And finally, we can insert any number in the queue. Else, the other cases where we can have, for example, this case, or we can say this case, or this case. All three cases are exactly the same thing. What we are doing, just we are doing rear is equal to rear plus 1. So in the else case, we are writing rear is equal to rear plus 1. So end of if, and finally we will set the value queue of rear is equal to num and then exit. So this is the Enqueue algorithm of simple queue. Next is the Dequeue. Dequeue means the deletion. So here also in the step number 1, we are going to check that whether queue is empty or not. So here we have seen the two cases where queue can be empty. Where first one is the front is equal to minus 1. When we don't have any element, the front value and rear value both will be minus 1. So that's why in that case, I can say queue is empty and we can say underflow. And one more case is front is greater than rear. If front is greater than rear also means all the elements we inserted already we have deleted. So we can say queue underflow. If this is not the case, then we can delete the element. And if we delete the element, we will return the deleted element first. So before doing front is equal to front plus 1, we will do is what? We will print the value that we are deleting. And finally, step number two is X.